All right, so let's take a look at this lesson. So I did this like little example here mainly because what I wanted to show is I wanted to show the side-side-side postulate. So the cool thing is that with the side-side-side postulate is that I could use the distance formula, right? And if I use the distance formula, I could use the distance formula to tell whether or not the triangles were congruent by side-side-side, because I could find the distance between 2 points. So I could find the distance of j to k, which would be 2 minus 1 squared plus 5 minus 1 squared. So I could get the square root of 1 plus 16, which is root 17, right? And then if I did like q to n, then I would have here would be -4 minus a -3 squared plus 4 minus 0 squared. And I would also get root 17. So now I could go and do another one and go KL, right? And I could do also NP. And then I could show that those were equal. So that would be like I'm using all these vertices here. So 1 minus 5 squared plus 1 minus 2 squared, which gives me 16 plus 1, which is root 17. And then here would be -3 minus a -7 squared plus 0 minus 1 squared, which also gives me root 17. And then the last one, they don't all have to be root 17. I go to J to L, and I go Q to P. And then when I do this one, I actually get 2 minus 5. Oops, not -2. 2 minus 5 squared plus 5 minus 2 squared. So I get square root of 18. Same thing here. I would go -4 minus a -7 squared plus 4 minus 1 squared. So I would get root 18. Okay, and then I would show basically that these sides were equal, these sides were equal, and these sides were equal. So because all three pairs of sides were equal, that they were equal by side-side-side postulate, or the triangles were congruent by side-side-side. And then there's another postulate that says if I have a side and another side and an included angle congruent, then there's a side angle side postulate that shows that these two triangles are congruent. So we're just going to be using this information in order to be able to prove the triangles are congruent. Okay, so what angle, if I have a triangle PEN, what angle is included between the given sides? So if I have triangle PEN and I have PE and EN, then I have angle E in between. And then if I had NP and PE, then my angle P would be included. Okay, here's HAT. And then here's angle H. So that would be sides HA and AT. And then angle T over on this side would be HT and AT. Okay. And then I want to name the postulate that you would use to prove that the angle or the triangles were congruent. Vertical angles are congruent, so I would have used side angle side. Here, by reflexive property, that third side is congruent, so I would have used side in the next one. Okay. Example 4 is a proof. So statements and reasons. So the first one is BC is congruent to DA, and that is given. And then the other thing that's given, which you could write in the same thing, is angle CBD is congruent to angle ADB. That's also given. So then my second thing would be BD is congruent to itself, which is reflexive. So then side, angle, side. So then 3 would be triangle BCD is congruent to triangle DAB by side, angle, side. Example 5, again, another proof. So X is the midpoint of AG and NR, and that is given. And then, so that means, too, that AX is congruent to GX, and that is definition of midpoint. And then NX is congruent to RX, also by the definition of a midpoint. Sorry, that should be 3. And then 4, angle NXA is congruent to angle RXG by vertical angles. So here those angles are congruent. AX is congruent to GX, and then NR is congruent to XR. So now what I have is these two triangles are congruent by side, angle, side, because I got side, included angle, and other side. All right, one more example. So statements, reasons. Okay, so now GK bisects, I cannot spell, angle JGM, and that is given. So that means that angle JGK is congruent to angle MGK. That looks like an R. So here and oops, wrong direction. Here are congruent by definition of angle bisector. And then 3 is GJ is congruent to GM, and that's given. And then GK is congruent to itself, and that is reflexive property. And then triangle GJK is congruent to triangle GMK, and that is by side, angle, side. And that is it for this lesson.